Okay, these are examples for exercise 311, definite integrals using substitution. There is one difference when we do definite integrals compared to indefinite integrals. Definite integrals have values on the integration sign. So what we do, we change the variable and do all that substitution into the equation and all that sort of stuff. But the change is that we change the limits of the integral to the new variable. Now, here's our first example. It is question 1a from exercise 311, and it's to find the integral between 1 and 0 of x bracket 3x squared minus 1 to the power of 5 dx. Okay, how do we start? Let u be, what do you think? 3x squared minus 1. So therefore, du dx is 6x, which means that I'm just going to write, for example, that du is 6x dx, but what do you think you're going to be substituting? You've got an x dx. Du is 6x dx. What should I do? Du over 6 is x dx. Okay? That way we've got that whole u dx is substituted with du on 6. The 3x squared minus 1 is u, so we've got u to the power of 5. Everything looks to be done there. This is the change now with this new type of question. See, these limits from 1 to 0 relate to x. They don't relate to u. So now we go. When x is 1, u is 3 times 1 squared minus 1, which is... So I'm working out the new limits. This is the only difference. See, when you put these limits in of 1 and 0, you put them into x values. Does that make sense? When you now put this all in terms of u, these are for, the 1 and 0 are for substituting into x, not for substituting into u. So what we do, we use this equation here that u is 3x squared minus 1. So when x is 1, u is 3 times 1 squared minus 1, which is what? What does it equal? 2. And when x is 0, u is 3 times 0 squared minus 1, which is negative 1. So now my question becomes, that is equal to the integral not now between 1 and 0. The 1 gets replaced with a 2 and the 0 gets replaced with the negative 1. Let's replace this. The 3x squared minus 1 to the power of 5 is u to the 5. And we replace the x dx with du on 6. Now, where could that 6 go? You can leave it underneath if you want, that 6. Or you can take it out. What do you want to do? All right, if you want to take it out. So it's 1/6 integral between 2 and negative 1 of u to the 5 du, which is, what do we got? 1/6 bracket, square brackets, u to the 6 on 6 between 2 and negative 1. 1/6, what's 2 to the 6? 2 to the 6 on 6 minus negative 1 to the 6 on 6. And now you can just work that out. So that's what? Is that 64 on 6 minus 1/6? That's 63 on 6. It's 63 on 36 then. Because that's 64 on 6 minus 1 on 6. Denominators are the same. So it's 63 on 6 and then timesing it by a 6. Actually, girls, that can be divided by 3. 21 on 12, which can be divided by 3 again. They're both divisible by 9, actually. 7 over 4. Units. Actually, no, don't write units, whatever. We're just evaluating an integral. 7 on 4. All good? Next question. Okay. All right, you can try the next one on your own. Let me just see what I'm going to give you. You can try, wait, I'm just looking at my exercise. I don't have Gloria here to give me the book. Hello, Gloria. All right, let's do question E. 1E, I'll write it out here. 1E, evaluate this integral. You can do it on your own. What do you think you're going to let u equal? Oh, you can't see it. U equals 1 plus x to the 4. Okay, get moving. So have a go yourself. Don't forget to change your integral limits. Oh, look, I wrote u equals u equals. What are you going to do? Oh, no. Just keep going. What are we going to do, Georgia? Oh, well, look at what you're, you've got x cubed dx. What do you just put the 4 underneath? Look at what you're trying to substitute. You've got x cubed dx, good. So du on 4, do you know what I mean? Is x cubed dx. Great. Okay, you can then change your integrals. So that's our original question. We make the new substitution. 2, 1, x cubed dx is du on 4. I might put that at the end. And we've also got 1 over u to the 5. So we're going to take that 4 out to the front if we want. So it's a quarter integral between 2 and 1. How do I write the u, 1 over u to the 5? U to the minus 5 du. Be careful as well when you integrate that you increase the power by 1 and don't decrease it by 1. So that'll be u to the minus 5. Take the quarter out the front. You get u to the minus 4 on negative 4 between 2 and 1. You might want to rewrite that. You may even take that 4 out if you wanted. See that negative 4? I'd probably take, whatever, it doesn't matter. 1 quarter, you'd write this, you're probably not comfortable doing it. Negative 4, you know, I'd take the negative 4 out, girls. See this one here? Girls, see that 1 over negative 4? I'd make it negative 1 on 16 out the front and then do the substitution. It would still give you the same answer, but some of you may not feel comfortable doing that. See this, you can substitute there if you want, but just be careful because you're substituting and you'll have a negative minus another negative. This is 1 over negative 4u to the 4. I personally would make it negative 1 on 16 out the front. I'd take that negative 4 out. But, I don't know, do you not feel comfortable doing that? It's the same as me taking this quarter out here. All right? I would take it and make it negative 1 on 16 and just substitute that. But if you're not comfortable with that, then don't do it. 1 over 2 to the power of 4 is 16, isn't it? Minus 1 over 1. Oh, what did you get? And then you can just do that on the calculator. Yeah, it's negative 1 on 16 times... That's 16 on 16. Negative 15 on 16. Did you get 50? What did you get? Yeah. You know why? Because you've added instead of subtracted. All right, if you're not going to pull this out, this is what you would do over here. You'd get a quarter. Then you'd get 1 over negative 4 times 2 to the 4. This is why it's dangerous. Minus 1 over negative 4, 2 to the 1. See, girls, doing it this way, if you don't take that negative 1 on 4 out, you can do it this way, but it gets really, really tricky. Like I'd be careful. You get negative 1 on 4, then you get 1 on, what's 4 times 16? Negative 64, but then you get a plus. Or you go minus, that's okay, keep it as minus 1 over negative 8. See, I wouldn't do it that way. That's why I'd take this 4 out. I would take this minus 4 out. You don't get any of these problems. See, and that's really plus 1 on 8. A quarter, negative 1 on 64 plus 1/8. Now 1/8 is 8 on 64. I would take the negative 4 out here before I substitute. Why substitute it twice? I would do it this way, but you only do it that way if you know what you're doing. If you're not sure, do it this way, but just be very careful. You've got a minus and a negative. All right? And you'd get a quarter times 7 on 64, which is, I'm not getting that. Thank you, I made a mistake. Oh, yeah. What did I do wrong? 2 to the 4. 1, thank you. So it's minus 4. See? Even I'm making mistakes that way. Plus a quarter, and then you get the other answer. What a mess. Have fun. Okay. Girls, can you see this is better? Do you get why you can take it out? I would take it out. The only thing you can take out are constants. Girls, you can take the constant out. Forget taking the u out. You'd never take that out. That's got to be substituted. Okay, next question. We're now doing question 2e. Can you please have a go now? The substitution is u is 1 plus x. Question 2e, when we get u is 1 plus x, du dx is 1, du equals dx. So the dx is taken care of. But we still have to make a substitution for the x. So go back and look at your equation. U is 1 plus x, therefore x is u minus 1. That's done. Okay, the bottom is done. So now I need my limits. When x is 1, u is 2. And when x is 0, u is 1. So now let's go with our integration. So your question now becomes integral between 2 and 1. X is u minus 1. Dx is du over the square root of, what do I write? U cubed. Now what do I do with this? Integral between 2 and 1. Yes, I've got to break it up. It's u over square root of u cubed, which is u to the what? It's 3 on 2 minus 1 over u to the 3 on 2 du. Girls, you need to break that fraction up. We don't do quotient rule with integration. All right? So, remember the denominator here is u to the 3 on 2. So it's u over that. So what do I do before I start? This is u to the 1 over u to the 1.5. What do I end up with? Don't you subtract the indices? What's 1 minus 1.5? Negative a half. So it's u to the negative a half minus, and we just lift the 3 on 2 up to the numerator. Got it? The only time you can break your fractions apart here is if there's one thing on the denominator. If you've got two things on the denominator, you can't break the fraction apart. See, this is just subtracting fractions with the same denominator. So if I had more than one thing on the denominator here, forget splitting the fractions. You can't do it. Okay? It's only if you've got one thing on the denominator that you can split the fraction up. We okay now, girls? So we've got u to the, remember you're adding 1. A half over a half makes it, oh look, I'll write it like that. Minus, what do we do now? Negative a half over negative a half. I'd be fixing up the way it looks before I go substituting. How do you write it nicely? 2 root u plus, what's this one? See, plus, because the negative negative, you've got 2 over root u. Got 2 root 2 plus 2 over root 2 brackets minus 2 root 1 minus 2 over root 1 plus, which is, girls, you could go common denominator here if you want. Oh no, you know what you do? 2 root 2. How can I write 2 on root 2 in a nice way? Come on. It's just root 2. Because 2 is root 2 times root 2. So that's the same as just writing root 2. You okay with that? Minus, isn't that just 2 plus 2? So it's minus 4. This is 2 plus 2, which is 4. So 2 root 2 is fine. 2 on root 2 is root 2 minus 4. Okay? Please give an exact answer. Now, can, which is, wait, I'm not finished. Like terms, 3 root 2, because that's 1 root 2 minus 4. That's an exact answer. Okay, next. We're back. Question 2b, integral between 1 and negative 3 dx over square root of x plus 3. This is the substitution that you're given. X is u squared minus 3. You do not need to make u squared the subject, otherwise you're going to have to square root it to do the du dx. So there's nothing wrong with doing dx du. So we get dx du is 2u. So that means that dx is 2u du, and that's a good substitution for up here. So that's good. Then we look over here, x is u squared minus 3. We want it x plus 3. Taking that 3 to the other side, u squared is x plus 3. We could just put that in there, or we can do the substitution down here. Square root of x plus 3 is the square root of u squared, which is u. Changing our integrals. So therefore, all right, so now we're doing this. Change our limits to 2 and 0. Dx is 2u du over, that's u. Dx is on top, which is 2u du over u. The u's cancel. It's the integral between 2 and 0 of 2 du. What do you get when you integrate 2? You get 2u. 2u. If you integrate 2, you get 2u. Which is, it's all right, which is 4 minus 0, which is 4. Aha. Okay. Now, not sure, Gloria, if I paused the video last time, but that's the solution for 2e, so have a look. I can't remember if I stopped the video or not. Okay? All right, next question. We're going to look at some, are we all done? We're going to now go to volume questions. We're going to go to question 7 in volume, and then I think we'll try question 10, and that's it. Question 7. I'll bring it up on screen. Can I move now? Here is question 7. Find the volume of the solid formed when that curve is rotated. Be careful, it's volume. So you've got to do pi b on a, integral b on a. All right? So question 7, they want the volume of the solid formed. Can you write the question out? When the curve y equals x times the square root of 1 plus x cubed is rotated about the x-axis from x equals 0 to x equals 2. All right, remember to set up your question and write out what the integral is going to be. You've got to put a pi out the front, remember? Oh, and it's pi b on a. Actually, you've got a bit of setting up to do. I suggest you write the formula out first before you even start anything. Y squared dx. Okay, what does y... So y equals x times the square root of 1 plus x cubed. Actually, wait, can I just look at that question again? Yeah, that's okay. So what does y squared equal? X squared, and you square this, and you just get 1 plus x cubed. While you're there, are you okay with that, girls? You are squaring the whole thing. So you square the x and the square root goes. Now what should you do instead of doing this as a product rule? Expand it. X squared plus x to the 5. That's what y squared is. Now you complete the question with that. Let me tell you, I think, can you finish it? I really need to, all right, go. Oh yeah, we got to do, oh, there's no substitution now. This is a nice one. It's an easy question, it's just normal. We don't need integration by substitution because look, if you look at, if I put that back in now, I've got 2 and 0, x squared plus x to the 5, you can integrate that. The only time you can't integrate is when you've got a product, 2 functions of x multiplied by each other, or the quotient of 2 functions. A function divided by another function where one's a square root or something like that. But this can be done normally. And you don't need to change the values. You just do it normally. You only change the values here of 2 and 0 if you're changing everything to u. Does that, girls? No substitution, no changing u's, no du dx's. It's a normal question. Okay? You should get pi x cubed on 3 plus x6 on 6 between 2 and 0. Remember, your answer is units cubed. Pi 2 to the 3, what's that? 8 on 3 plus 64 on 6 minus 0 plus 0. x6 on 6. What do you mean? It was an x to the 5. It becomes x6 on 6. I'd go common denominator of 6. That's 16 plus 64 on 6. What's that? 80 on 6, 40 on 3, 40 pi on 3 units cubed. Right. Next question. Girls, I've actually got to go.